Hello friends, grab your coffee, grab your cookie, and maybe shake the sand out of your shoes, because today we are talking about sand dust. Yes, that heavy, gritty, stubborn dust that somehow gets into your hair, your equipment, your ductwork, and every moving part that never asked for lubrication by sandblasting. My name is Michael Klepik, and for 15 years I have been designing dust collection systems for sand handling, foundries, concrete plants, blasting operations, bulk mineral processing, and construction material manufacturing. Let me explain what sand dust really is and how we keep it under control. What sand dust really is: technical description. Sand dust consists of fine mineral particles, often containing crystalline silica, released during crushing, screening, conveying, or sandblasting. Technically, first, particle sizes range from 1 micron to several hundred microns. Second, the most airborne and harmful fraction is typically from 1 to 10 microns. Third, bulk density of loose sand dust is high, often from 1,000 to 1,600 kilograms per cubic meter. Fourth, airborne concentrations can reach from several hundred to 15,000 milligrams per cubic meter in heavy sand handling areas. Fifth, the dust is abrasive and wears down ducts, fans, and filters. If the sand contains crystalline silica, the dust becomes especially hazardous to human health. Where sand dust appears in industry, you will find sand dust anywhere. Mineral materials are processed. First, sandblasting and abrasive blasting operations. Second, crushing, screening, and drying systems in aggregate plants. Third, foundries handling molding sand and core sand. Fourth, concrete and cement facilities handling sand aggregates. Fifth, construction material production using quartz sand. Sixth, glass production lines where sand is mixed with soda ash and limestone. Seventh, bulk loading, unloading, and transfer points. Anywhere sand is moved, dropped, crushed, or blasted, dust appears. Why sand dust is dangerous? Sand dust introduces several major hazards. First, if it contains crystalline silica, it can cause silicosis, a serious lung disease. Second, fine quartz particles penetrate deep into the respiratory system. Third, sand dust is extremely abrasive to equipment and ductwork. Fourth, it reduces visibility and creates housekeeping problems. Fifth, dust layers interfere with sensors, bearings, and electronics. Sixth, although not combustible, sand dust can increase the severity of combustible dust events by displacing other materials. Sand dust is physically heavy, but respirable silica is extremely dangerous. Physical behavior of sand dust in airflow. From an engineering perspective, sand dust behaves differently from organic or polymer dust. First, it is dense and settles quickly if airflow is not strong. Second, it erodes duct elbows, fan blades, and filter housings. Third, it accumulates in low-velocity areas of ductwork. Fourth, the smallest particles, from 1 to 5 microns, remain airborne the longest. Fifth, abrasive blasting produces extremely fine dust that behaves like smoke. To keep sand moving and prevent buildup, I designed duct velocities from 4,000 to 5,000 feet per minute. What filtration equipment works best sand dust? Requires rugged filtration systems designed for heavy abrasion. For fine silica dust, a faux and cartridge collector is effective. First, it captures fine respirable silica particles efficiently. Second, it provides a large filtration area for continuous operation. Third, membrane-coated cartridges prevent deep dust embedding. For high load or heavy sand carryover, a Baghouse Blizzard is often the best choice. First, it tolerates heavy abrasive dust loads. Second, it handles high inlet loading without clogging. Third, it offers long filter life with proper abrasion-resistant bags. Abrasion protection. Sand dust requires special design features. First, abrasion-resistant duct elbows. Second, inlet baffles to reduce direct filter impact. Third, ceramic or hardened steel liners in high wear zones. Fourth, pre-separation cyclones when load is extremely heavy. Capture hood designed for sand and silica processes. Because sand dust falls quickly but fine silica floats, hood design must be precise. Effective capture methods include: first, enclosed hoods on crushing and screening stations. Second, containment booths for abrasive blasting. Third, side draft capture for sand transfer points. Fourth, multi-point extraction at foundry molding and shakeout lines. Fifth, dense phase conveying enclosures for dry mineral transport. Without proper enclosure, fine silica escapes into the air instantly. The most common mistakes I see with sand dust. Across sand handling and blasting facilities, I frequently see these errors. First, using standard ductwork without abrasion-resistant linings. Second, running too low air velocity causing dust deposition. Third, using filter media not designed for silica dust. Fourth, ignoring respirable silica hazards and OSHA requirements. Fifth, not enclosing blasting operations. Sixth, allowing dust to accumulate in low-velocity sections of ductwork. Sand dust punishes poorly designed systems fast. What I always do on sand dust projects: my engineering approach includes: first, determining silica content in the sand. Second, measuring airborne dust fractions from 1 to 10 microns. Third, designing ductwork specifically for abrasive materials. Fourth, selecting filters that resist erosion. Fifth, including inlet baffles and pre-separators when needed. Sixth, enclosing dust generation points to reduce escape. Seventh, ensuring the system complies with silica exposure standards. These steps ensure safe air quality and long equipment life. Sand dust may look like ordinary dirt, but fine silica particles make it one of the most hazardous industrial dusts. It is abrasive, airborne, persistent, and capable of damaging both lungs and equipment. With the right airflow, abrasion-resistant design, and efficient filtration, we can control it safely and effectively. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, sand belongs on the beach, not in your ductwork. See you in the next video.